Hello, this is Mr. Huebner. In this video, I will be doing a demonstration on bonds, polarity, and solubility for your lab. Hopefully, you can do your lab at home. I'm trying to do it with very common kitchen items, but if you don't have them, then definitely watch this full video so that you can basically make your observations based off of the observations that we're going to be making on this video. I got my wonderful lab assistants with me today. There's Bethany. Say hi, Bethany.
Hi.
And then there's Josiah.
Hi.
Hi. And then there's Calvin. Hello. Say hi. Oh, well, he doesn't want to say hi today. So. And my lab assistants are one step ahead of me. They have their safety goggles on, which is something you always want to wear. Although, if you don't have safety goggles with you for this experiment, it's totally okay. Because, yeah, Batman sunglasses work if you have those hanging around. Or if you got some toy shop goggles, those would work. If you don't have anything, in this case, it's okay because the most dangerous thing we're working with is rubbing alcohol, baking soda, I guess you could say nail polish remover, but it's all stuff that you work with at home. So it's pretty safe. But it's fun to wear goggles. So if you got them, I'd wear them. All right. So in this lab, we're looking at basically solubility and how it relates with polarity. And essentially, likes dissolve in likes. So if you are having a polar substance, then it's going to dissolve in something else that is polar. Or if you have a nonpolar substance, it will dissolve in something nonpolar. However, if you have a polar substance and a nonpolar substance, they are not going to mix. Something like oil and water would be like your common example, although I don't want to get into it too much because that would ruin the surprise of the experiment. So here we are. We got to look at, first of all, is water polar or nonpolar? Here's the Lewis dot structure. And a quick, easy way to determine if it's polar or nonpolar is if there is symmetry or no symmetry. So like water right here, it looks like it's symmetrical left to right, but then if you cut it top to bottom, you got H's on the bottom, lone pairs on the top. That is not symmetrical. So if there's no symmetry, then it is polar. So it looks like water is very polar, which would suggest that anything that dissolves in water would also be polar. If it kind of dissolves in water, but not totally, then it's kind of polar, but not totally. And it would probably make sense looking at this one. We've got basically vegetable oil, olive oil. They're all going to be mixtures of various fatty acids. And the main component of a fatty acid is the chain. It's a long chain, a lot of carbons and hydrogens. And as we see, it looks like it's symmetrical left to right and top to bottom. So if it's symmetrical both ways, that would suggest it's, you guessed it, nonpolar. All right, moving on to the experiment. Got a bunch of different directions, but essentially you can modify them to whatever works for you in your kitchen. We have, we're going to have one jar we're going to fill with water, and one jar we're going to fill with vegetable oil. I only have a few clear utensils that can contain liquids in my house, so I'm going to have to be washing them a bunch of times. If you need to do that, it's fine. So looking here, I got water. I'm going to mix it with vegetable oil, and I'm going to write my observation. What do I see? Do I see it mixing, partially mixing, or not mixing at all? I'm then going to take a different cup and fill it with water, and I'm going to add some salt to it, and I'm going to see what happens. All right. Are you guys ready for the experiment? They are ready. So we need to get some water. I'll fill these two with water.
Yummy.
There's some water. We'll get Bethany gets to do the first one. Josiah gets to do the second one, and Calvin does the third. And it looks like we have vegetable oil
For me.
is right here. So, Bethany, do you want to do the honors of pouring just a little bit, not the whole bottle, just a small bit? I'll say when. Okay, perfect. Did that get into... Did we get that in there? Ah. Now, can we see? Okay, let's pour some more in there so we can really see this happening. Bunch of vegetable oil. Look at that. Wow. Can you guys see that? There it is. It looks like you can see two distinct layers. All right. So in that case, what we'll do is we'll write our observations. And I'm going to say, did not mix. Two distinct layers. And I spelled distinct wrong. It's with a C. There we go. All right, next one. We're going to do water with sodium chloride or table salt. All right, Josiah, so you get to do the honors for this one. Let's pour it right in there. Look at that.
Wow.
So now let's mix it.
What?
You see that? Can we make this page bigger?
Bigger. I want it to get bigger.
Oh, gotta pause it. Okay.
Pause it.
Well, anyways, there it is. It looks like one thing, like it totally mixed. I don't see any salt anymore. All right, so I would write in my observations, mixed completely.
Mix it forward, right?
Well, I don't want to, they have to analyze the data later. Oh. So, all right, so let me clean these dishes off real quick so we can get ready for two more experiments. I'm going to press the pause button. All right, here we are. We're back with two new clean glasses of H2O. And we've got Calvin that's going to do the next one. I'll have to move the screen a little bit. Can you see it? There it is. All right, and we're dealing with glucose, sugar. All right, so Calvin gets to put a scoop of sugar into the cup of water, and we're going to see what happens. You ready? Look at that. Nice. Now we're going to stir it. Let's see. Oh, here we go, stirring it. And look at that. Looks like it resulted in the same type of observation as the salt experiment. I don't see any sugar anymore. Looks like it fully dissolved.
Like mine.
All right. Excuse me, Bethany.
It's like mine.
It's like Josiah's. So, we're going to say mixed completely. All right, next one is toluene, which is pretty similar to what's in nail polish remover. So,
my
we
turn.
got nail polish remover.
And then my turn to do it. It teaches like peeps.
Sure.
Okay.
All right, so just a little bit, Josiah.
Watch it.
Okay, Mommy's not going to be happy about that, but oops.
That was too much. I'll get more.
Ooh, blue.
Blue.
It's like at the ocean.
Don't drink it.
Okay.
All right,
Ew,
so
no, thank you. No, thank you. No, thank you. No, thank you. Ew.
all right, so
What's next?
it
What is
looks
Next.
Does it look mixed, Bethany?
It looks blue.
Does it look blue? Yeah. Well, actually, I can see a little stuff at the top.
Yeah.
Oh, yeah, I can see it. So now that it's settling, there's a very, very fine, and you probably can't really see it in the video.
See my face. Oh.
But I can see it really clearly now. Well, not clearly, but there's a faint line that's right, just a tad bit beneath, right there. So at the top is toluene, and the rest is H2O. So essentially, it's not mixing. So that's a tricky one. It is not mixing.
Interesting.
Should suggest that toluene or nail polish remover is the opposite polarity of what water is, because they're not mixing. We know water is polar. But all right, let's move on to baking soda. But again, I got to do the dishes real quick. 1 second. Hey, I'm back with 2 new cups of water. We got baking soda is the next one, also known as sodium bicarbonate. And my lovely assistant Bethany is going to be facilitating the baking soda drop into the water. Yep, just pour it right in. We got plenty of that, so yeah, you can pour more in. You can put more in. All right, here we are. Whoa, can barely see it already, and I didn't even stir it.
Whoa, it's water.
Put more in.
It's like it's water.
It's, Bethany, what'd you say? Is that mixing pretty well with water?
Looks
Yup.
like water.
Looks like water. So that mixed really well. I'm just going to say
Mr.
mixed
Body Mover.
completely. All right. Next we got rubbing alcohol. And I believe, Calvin, you want to do this one? Okay. Well, actually, I got a little bit left. So, and I need this for the experiment. So Calvin's going to get the next one. Sorry, all right. So, here we are. Let's look at this. This is rubbing alcohol. It's going to be a hard one to see.
I think it's going to be like water.
Might be like water.
Like baking soda.
Okay, I'm seeing a lot of the particles of water just kind of suspend throughout.
I can see the
Can you see it?
Yeah.
Yeah, look at that. It's kind of acting like the toluene a little bit, or the nail polish remover. Smells like rubbing alcohol. Probably just made 5% proof alcohol. And yeah, I'm not seeing it rise to the top much like toluene, but I do see some suspended a little bit. And again, on the video, it might not be picking that up. Essentially, it looks like it completely mixed. I know from experience, though, that rubbing alcohol is only supposed to partially mix with water. So, well, actually, I might be giving too much of the experiment away. So forget I said that. So we'll just say mixed. I'm not sure if it mixed completely, but it definitely mixed. All right. So it looks like we got all the experiments with water. Next, we're going to be doing the same experiments only with vegetable oil instead. Remember, if you have canola oil, sunflower oil, olive oil, it doesn't matter. It's all going to react a similar way. You know, they're all similar compounds. And essentially, they're all mixtures anyways. It's not a pure substance. All right. I'm just going to do some more dishes real quick, and I'll be right back. All right. I am back. I cleaned the dishes, and we are ready to do vegetable oil. And if we look at this first column, we're going to do vegetable oil with vegetable oil. Well, that doesn't make sense. So we can skip that because it's probably going to mix. Vegetable oil will mix with itself. So why don't we skip it to NaCl. I'm going to pour some vegetable oil in 2 of these. Here, I got it. We got vegetable oil, vegetable oil. I think I got some extra. All right.
More in this one.
And then, there's more in that one? All right.
That's in here.
All right, NaCl we're going to pour in. All right, so Calvin has this one, and he's going to pour NaCl in there. Let's make sure we have it so that we can see it in the camera. You see that? There we go.
What?
Did you get some in there?
I can see it.
Yeah, let's pour some more in there.
Wow. It's like ice.
It's like ice. All right, I'm stirring it. I'm stirring it. I'm stirring it.
Lemonade.
What do you guys think? Did that mix, or is
It
it?
looks like lemonade.
Looks like lemonade with pulp. So you can see that in the video. It looks very cloudy. It's because all of the salt particles just kind of suspended in the vegetable oil, so it's not mixing. All right, so we know what to write first. Right here, does not mix. All right, next we're gonna do glucose.
Can I?
Bethany's gonna do that one, and she's gonna take a spoonful of sugar and pour it right in. There we go, a nice big spoonful. Stirring, stirring, stirring. All right. And there we are. Again, it looks just like the last one, where there's a whole bunch of chunks at the bottom you can kind of see. Yeah, so it's certainly not mixing at all. All right, so does not mix. So that leaves us with 3 more. Let me wash these dishes out. We're back, and we're left with the people that have the longest attention spans. It looks like you and me, Bethany. All right, so we're going to continue doing vegetable oil with toluene. All right, so we got to pour vegetable oil. Pour some in here. And then we'll pour the rest in here. Looks like I'll have to pull out the new bottle of olive oil for the next one. We got enough. Yeah, we got enough in there. Okay. So the next one's toluene, and we want to put a little bit. Here, I'll do this one so Mommy's not too upset. All right, here we go. Vegetable oil with toluene. All right, so here we go.
Sparkly.
And it looks like it's sparkly. It's all bubbly inside. So,
Calvin. Pick something else to
is it mixing? It looks like it kind of is mixing, but not totally. Now, unfortunately, I'm using vegetable oil because it's a common household item. Ideally, it'd be nice to use hexane. Hexane is purely 100% nonpolar, totally symmetrical. Vegetable oil, unfortunately, is mostly nonpolar, but it does have a polar carboxylic acid portion with a C double bonded to an oxygen and an OH group, which makes it mostly nonpolar but a little polar. So that's why we're having these weird results. It's looking like it's mixing, but not totally. All right. Kind of mixing, we're going to say. Kind of mixing. All right. Moving on to baking soda. And Bethany's going to pour in the baking soda to that vinegar. There we go. Mixing, mixing, mixing. Look at that. What do you say, Bethany? Is that mixed or not mixed?
It's a little mixed.
It's a little mixed. Yeah, but it's mostly just suspended in the what do you call it, vegetable oil, and there's a big chunk that's just sitting at the bottom. I don't know if you can see that in the video. Yeah, so we're going to say doesn't really mix. And that leaves us with one more. And here, I actually have a clean dish right here. We'll just get that knocked out. But I need to get some vegetable oil. Let's see, pure olive oil. It's a little bit different than vegetable oil, but it's essentially the same thing. Mostly nonpolar fatty acid chains connected to a small polar region.
Take it easy on that. Take it easy.
Cap's already off.
Oh, the cap's off? Oh, all right, there it goes.
That's it.
Okay. So there's the olive oil. Now we want to do rubbing alcohol. And just a little bit, not all, because that's all the rubbing alcohol we got left here. Oh, okay, there we go. All right, let's look at that here. Ooh, look at that. Now that's interesting. So you can see two distinct layers for sure. Well, I can, but can you in the video? Oh yeah, you can see that nicely. Look at that. So we got rubbing alcohol and vegetable oil. They're not really mixing. No? Well, yeah, we'll say that. Doesn't mix. Makes sense because, well, I don't want to give away the answer because then you wouldn't have anything to do. All right, what did we say it was? Did it mix?
No.
Did not mix. Okay. All right, so there we have it. Those are all of our results. You then have a bunch of questions to answer. Which liquids used in this experiment? No, not iodine. Vegetable oil. I gotta update this to make it more applicable to the kitchen for you guys. And then there's some questions here. Oh, and then there's some predictions based off of whether they are polar or nonpolar. You can look at the electronegativity difference table to determine if it's polar or nonpolar. Or you can look at the symmetry of the Lewis dot structure. If it's symmetrical, top, bottom, left to right, then it's nonpolar. If it's not symmetrical, then it's polar. So different ways you can look at that. And that's about it. If you got questions, you know where to contact me. That's Mr. Huebner doing the Polarity Lab. And Bethany, can you say bye?
Bye-bye.
Bye.